Hello, you are welcome to the hands-on section 2 of the AI and machine learning series. So today, we'll be working on the project house price prediction project, which was mentioned in the last section. We were unable to do it because of time, but we did Titanic prediction, the survivor, whether a passenger will survive or not. We're able to build a model to predict that, and we're able to also evaluate our model. But today we'll be going into house price prediction. Yeah, so I'll be going to my notebook. So this is a previous notebook of the project that I've run before. So, but I'll be creating a new one afresh. So just for you to be able to follow through. While running, any error we face, you will also be able to see it and how we are able to solve those errors and all that. So I'll be starting because I've used the notebook before, and we won't have to be installing all of this again. They have latest version more than this, because this has been done like a year ago. So I'll be importing pandas. Then we'll be using our Scikit-learn, that is Scikit-learn. We'll be importing our model from it, and we'll be importing the train test split. I believe in the section 4, if you are following us, you understand what the train test split is for now, where you split your data set into the train and the test set. Though for the Titanic prediction, we didn't import this because we already have our data set splitted. We have the complete data set as well, but we have the ones that are splitted into train and also test data sets. So we just get the link for the website where it is located, and we just import it and use it directly in our code. But now this one will be, I have the data set, which is the name Nigerian houses. So houses in Nigeria, they are categorized based on the numbers of bedrooms, toilets, parking space, the title, whether it's a duplex, is a bungalow, and like that, the town where it's located, the state also. Then we have the price. So now based on the price, we also try and create like a form of category to categorize them based on price. Maybe a expensive one, budget house, affordable. You can categorize them. Then we try to encode um, the prices. So giving them maybe a price category of, maybe for expensive you give it one, for affordable. Just this has been done because normally when you are working on a machine learning model or a model, AI model generally, you need to process your data. But for our data, I think the processing has been done. That's why we're able to have this price category. But we'll still check before we proceed. So let's first start by importing all these. Then we'll be using linear regression. Reason why we are using linear regression instead of logistic regression. Logistic regression is use of classification. Why linear regression is used when we need to predict values, numbers. Now we want to predict numbers. We want to predict values. So that is the reason why we are using linear regression. I will be importing some metrics, which is the mean absolute error, MAE, and the MSE. The MSE is called the mean square error. So we'll be importing those metrics to be able to use it to evaluate our model. So let's start. So we're starting with here. So importing pandas and all this. So let's run it, because this is the first time. This notebook has already been created in the last session. So that's why I open the notebook and we start working with it. So let me run the cell. So connecting to a runtime. because this is the first time, that is why it's taking time. I'm trying to create a new code cell down. While that is still running, we'll be importing, we'll create a data frame. We'll be importing using PD. Pandas is used for our data frame. Let me close this. PD dot read. The data set is available in CSV. Then read CSV. You can see the file. You can read the HTML, JSON file, Excel, further. We are reading CSV file. Then we'll put the location here. But before doing that, this has already run successfully. You can see the time for running 1 second. I need to import my file. So you come here where you have your files. Then you upload. But sometimes when you have heavy or big data set, and if you upload your data set here, is for this runtime. When this runtime or sections disconnect and I had to start the section again, I might need to re-upload my data again. But if you are uploading it to a drive, mounting your drive, you already have your data installed on your drive. You just mount your drive, copy the link to the data set on your drive and just place it here. So it saves you time of having to upload, because when you are uploading here, the network might be slow, and if it's an heavy data set, it will take time. And now imagine having to wait that long to upload your data set, running it, maybe something happened, you disconnected the runtime and all, you have to re-upload it. Why not just upload it once on your drive, then you just use the link. It's easy to use. So I'll just mount my drive. Note the drive, the Google Drive you'll be mounting will be the Google Drive attached to your account. So connect to Google Drive. Then we'll try to authenticate your account. You can see I have more than this account here, but thank God it's only bringing this because this is one I have attached. Still mounting. So trying to sign in, then so once it has finished mounting, you see it. Can you see? Now if I press it, it will mount it, but it's already mounted. So this is my drive. You just open it, then you locate where your data set is. Then I've created a file for it already. So I'll just go, this is the data set. Then I'll copy the path. Can you see? Like I will come inside there and paste the path here. Put your apostrophe there. Then next line, I want to be able to view the head. Let me run it again. Enter pf.head. At least the first 5 row. Sorry. And you see now, you can see what we have. Let's try and view the tail also, the ending part, and see what we have there. Almost everything is having price category of 111. So I feel, well, since we are not going to process the data, so we don't know what was used to process the price category. We can see different prices here. How many zeros do you have here? 3. Another 3D is 50 million. Like that. These are the numbers of, you can see the numbers. So we need to still check if there's any missing data, duplicates, columns or rows, mostly duplicate rows. Then if there is no other thing we need to do, then we can now proceed to split our data set before building our model. So let's dive back. So now we'll check the info. The info, what it does is it will show you. You can see now, based on the total numbers of entries, you have the numbers of rows, 2, 4, 3, 2, 6 rows. So if you have this no means the rows that are not empty, no empty rows. So these rows, the total number of rows we have here, and we're also having them here, that means we have 0 empty rows. Let's say this one is having 320 no rows. That means we have maybe 6 rows empty. Then we also have 9 columns. So you can see, and based on the different data types we have there. So let's proceed. Do you have any missing value? Since this one is used to undo missing value, but since we do not have missing value, this was used for another, right? This was used for car price prediction. That's why you can see engine and the engine, the manufacturer, and all that, year of manufacture. So no missing rows in our columns. You can also check duplicate rows and check for that. Then if we don't have that, we create a label encoding. So before that, let's check. Let me just use this df info just to run it again and for you to see. Let me check duplicated. Let me see. So now this is giving false. Then it's as if you have one rows that are with. We have some rows that are duplicated. Likely, it's as if you have some. So now let me add some. This is showing all the rows. This will give me the numbers of duplicated rows that we have. So this will give me the numbers of duplicated rows we have. Wait. How come? How many rows here? We have 24,000. So we are having 10,438 duplicated rows. Let me add a column. I want to view some of it and be able to see that and see the rows. This data is much. That is why I'm trying. If it's not that much, I will have dropped it initially. But since it's much, that is why I'm careful of not dropping it. So I need to physically check, or wait, let's check our data set. I don't know, let's see if we can explore our data sets as well. And that is running. We have 24323. It's like this ones are duplicated, this and this are duplicated. We check that. 2235. Two, 4, 3, 2, 1. From there, we start from 2, 1. There are some before that place, but it has helped us 2, 4. Two, 4, 3. This is 2000. Let's see, going down. I just download this and start. Let's also explore from here. Also explore from here. You see anyone that loads first? And we could just save ourselves the time and just drop them. But really, the reason why we are careful, because if you split our data set, let's say one of the data sets we have duplicate rows, and one of it falls in our test set and one of it falls in the train data set, train set. By the time we use it to train and it's seeing that same thing in our test set, automatically it knows the answer. That is the kind of data leakage. So which we want to try and avoid. Yeah, 2432. Let me start from here. 2430. This is 2000. Okay, this is 24321. Yeah, from here to 24326. You can see, okay, where is 24321 and okay, 22 and 23. 21, 22 and 23. It's like this row is duplicate. These two rows. Let's check this ones. Block of flats. This one is detached duplex. And we have Ado Odota, Lekki, Ogun, Lagos. It's like it's different. So let's just leave it. Let's leave it and assume, because what we're having there is somehow different. It's just like the first part, like in the name, is kind of different. This is where we are now. So while that is loading, let me just collapse this one. Let's move to our next. So we are not dropping. This 24. This is the one like it's looking like as if it's different, but different price. You can see it. This one with block of flats. You can see okay, 2, 5 different numbers. The price category is the same for everything with what I'm saying here. Mostly are Lagos, Ibeju, Lekki. You can see the names different. Some might have the same numbers of bedroom and all that, but different. So this data has been processed, so no need of stressing ourselves. So I believe that would have been addressed. So let's proceed to encoding. So from SKN pre-processing, we'll import label encoder. Since we didn't import it in the beginning, we have in SKN, we have the label encoder, we have the one-hot encoder. But we'll be using label encoder. Label encoder, based on the labels, we have maybe the house, type of house, we just give it labels. When you see this house, you give it one label. When you see this type of house, you give it this label and all that. Then for all one-hot encoding, we've done all this in the previous section, all the type of houses we have there. So when we have 0, maybe we just have 001. For each type of label, we'll be having 1. But when we are having maybe duplex, we'll be having 1 and every other label should be 0. Just like a kind of a array. That is just the way one-hot encoding is. So let's create our encoder. Even while still copying from my previous page, I'm still checking to correct errors and some things So I'll still correct some of the names here. So now let's go to our data now. This should be on a single line from SQL import label encoder from SQL processing imports. Yeah. So let's go to our data set. We have title. All these ones are the ones having names like characters, yeah, text. So we have strings rather. So we have title, town, state. These three. So these three are the one having it to encode them. These are the states we have in our. So we encode those three things. So LE, we are using LE to represent our what? Label encoder for title of the house, type of house, label encoder for the town where it's located, label encoder for the state. You can see them, label encoder. Or we can also use it as once. Let me even use it at once to save us the time. You can see the way you can use everything at once. Ctrl C. You see how to use it. That is this copying, splitting things. The essence of the code just to save time. So this one done. I'll move to that of town. Back then I also have this. Once I'm done, I will explain what you are trying to do here. Then this is for state. How many instances do we have here? We have 3, title, town, and state. So we also see that we're having 3 here. We can see title, town, and state. So in our data frame, which is what we create using Panda DF, so you can see we have title, town, and state. So we are now saying anywhere we have that title, it will apply the label encoder instead. So LE title, which is the label encoder. But if I'm to do this directly without creating all this, I'll just let me bring all these 3 here. I'll just change what we have here to label encoder. Label encoder. I'll copy it because you can see what we have in these 3 places are the same. So just put label encoder directly. Let's run it to see if it will still run. It's bringing an error somewhere here. Label encoder not defined. Oh, sorry, I didn't import this first. So let me copy all this onto X. You know, I had to let me import it. Already imported. So let's run this. You can see it has already run. So instead of we wasting, you can decide to split it if you want, or you can decide to run it. whatever you have here, if you still run this and run this, it's still the same thing, because this LE title is what is assigned to LE title. We have label encoder. So since it's just label encoder, that is the three of them, no difference. You can just decide to put it directly. Let me just add a comment here, or create a label encoder instance and apply a label. Sorry, what is it? I've put something where I should not have put it, but I will correct that. Control C. Yes. And I don't know how I place what you have there. It's like that, is gone. Let me just pick it here. And apply together at once. Instead of doing it separate, you can do it at once. That's what this means. Let me just run this. So then we now go on to split our data set. We now go to splitting of our data set, where we split our data set. And remember, we said we have the target and the future. So the target is what we are trying to predict, and futures. The target can also be called our labels. Yeah. So we split our data set. So we split data into features and targets. So df drop. So we want to drop some columns. The reason why we are dropping some columns is if you didn't drop it, it will give an hint. And rather for the X, which is our features, price is what we are trying to predict. Rather, we are trying to predict price. So that is why we are removing price from this S. This is still our data set. Later we'll now split it into test and train splits. Or we should have done the test and train splits. So let's still see. So now we will drop the column, which is price and price category, because both are related. So we just drop anything having to do with price. Price is what we want to predict. So we split our target into it. But before that, we need to still split our data sets. Trying to check, okay. It needs to have been split somewhere. Which I skip or what? If it's not there, I'll split it now. Okay, I've seen where we split it. So let's run that. This is where we split our data set. So this one we are just splitting into X and target Y. Then after this is when we now split our data set. X. So now what we now need, from this X, we need X for S train and S test. We also need Y train and Y test. Y test, we will use it later on when we want to evaluate. So For the train test split, we have X and Y. This is our data set, X and Y. We'll split it there. Then we have our test size, which is 25. So that means, let's say we have out of 100%, we are splitting it in ratio of what? 75, 25. We have different split ratio. You can try to do 80, 20, 60, 40, 70, 30. But this is 70, 25. And this random state is for you to be, is like a key for, or a seed, where if you split, if another person runs this code and splits with the same random state number seed, we will get the same split for our test and train set. But if I should change this number, the split will be different. So that is just for reproducibility. That's why we have that. So now we will now be using finding the shape of our S and Y data sets, so that we will be able to know how many. So we'll be able to know how many we have there. We have already split. We have this 18 to 4. This for train. We have 7 columns. We out of 9 columns, we've dropped 2, which is the price and price category. We have 7 columns left. And out of 24,000 plus data sets, we have 18,000 plus in our train. So the rest is for our test split. So we are moving gradually. Then we will also check for the test. Then we'll start using our linear regression. We'll start building our model. Let's check for, let me add for test here. We'll start our data set building. So to print everything at once, so I will know this is, oh, something is missing somewhere. Yeah, these are for the train, while these are for the test. I don't know why it missed the last column there. Let me even try and put it in different. So, X. So now we'll start building a model. Before that, let me input a test here. Building our model using linear regression. So let's move to our code here now. We've already imported linear regression from the beginning of our code. So we are importing our model now. We've imported it, then we'll start. Just copy everything at once, then we'll start. I will explain also. So let's first start first, then we'll see if we can use decision tree. So now I'll be starting with this linear model. I can try to just give it model. Alright, and linear model is equal to linear regression. But the reason why I will just leave it as linear, you can decide that we want to use another model to predict. Maybe decision tree, yeah, that is the best you can also use. So that is why, just to differentiate the model we are using. The other one, I can name that one tree model and all that. That is why I would leave it as linear model, that is linear regression model. So then after it will fit is used to train our data. Already said in the last class, fit to train data, evaluate to evaluate our data, and all that. Predict is used to check and to predict our test sets to see if our model, to get the answer results here from our model. So let's run this. So it has finished training. Then we have let's predict now. So now we want to predict linear prediction. That is linear regression prediction. So linear model, which is what we have here, linear regression. That's a linear model. Dot predict, which is what I said. This is fit for training. This is for predicting. Then what are we predicting? We want to predict our S test. Notice here we use S train and Y train. It will train from S and compare it with Y. But now when we want to predict, we just predict with an S test. We are not using Y test. The only time Y test will be used is when we are evaluating our model. We now want to compare the results we get with our model to see if they are what? They are similar, to calculate the accuracy. So linear prediction. So this is an array of the results. So I can, let's also bring a Y test. Let's check the numbers of prediction we have first here. How many prediction? Normally, if you should check our prediction, it should be giving us this shape that we have here, 6082. And you see what we have here also, 6082. That means it's predicted for each of every of our what? Of our rows. Then let's check our Y test. We still evaluate also. So for the first one here, we're having this around 8 or something. The last, we have 7. Numbers of 0, we need to be careful. This 370 million. This one here, we average per 8. How many 8 is? That is like 6 something more. Let's evaluate our model. Let's evaluate. Let's check out the time. This is for making predictions. Let's evaluate our model here not. This is using random key. I'm checking for something here. So now let's proceed to our code. Then we've predicted. We'll still use another model. Now we'll be using decision tree also. Use decision tree. Then we will now compare the results. In decision tree now we will have our evaluation metrics. We'll check for the mean absolute error, the mean square error. We'll define them. Then we'll use it to evaluate our metrics for decision tree. This is it for linear regression. This for decision tree. Okay, let's try and work with stuff first. Then we'll start predicting. We'll start evaluating rather. So let's first start with decision tree again. Let's use decision tree. Then once we are done there, we'll now start evaluating our model to see which one is accurate. You see that we have the tree prediction. So let's start with that one first. Using decision tree. So we first import decision tree, decision regression. Then we have we create the tree model that we train. Then we also now have after training we predict. Let me put everything together, then we run one by one. After training, we'll do what we predict. And I also check for length of, and this is number. That length means we have what is the numbers of the tree predictions we have. So now let me try running from here. Done. So now let's move to evaluating our models. We also try and do this one and also to see if you can check for accuracy also. Sorry. So now we are defining our evaluation metrics. You remember we imported this mean absolute error. So our metrics will be the mean absolute error. This is just our string. Then it will print the mean absolute error, mean square error. We should have imported accuracy. I'm trying to check where I use accuracy the last class. As I had to open back up. But let's finish this. So now we will now have results. It will save the results here. For name and function in this metrics item, it will calculate the score for each model. Linear score and function y test, the linear prediction. For tree score, it will do the same thing. Then it will store the results in what? In the dictionary, the results name. Then we have the linear regression score, the tree score. So this is to evaluate our model. Let me see if I can add accuracy also to the code. So let's first run this. We will now check our accuracy later. There's an error somewhere here. Linear score indentation. Where is the first statement? Okay. Tab. Then for this, tab. Tab. Let me see an error will still be somewhere there. So let me call results here. Let me still put results. Results. Now call result. Let's see if it bring it out. Sorry, I'm putting. Let's see. I feed in the detection error. Okay. Let me check if it's even the same with what we have before. For decision tree, have mean absolute error, we have 389431. For mean square error, we have this. So it's only bringing for mean square error. What about mean absolute error? We're not having that. So something is wrong somewhere. Sorry, let me check my code. Okay. This should also have an indentation. So, then this. Alright, let's run again. Let's see if we get for all the metrics. Yeah, we have for all the metrics here. 3893. How come is having a large number? Right. So this is the mean absolute error for both of them, and this is the mean square error. So let's say this having linear regression is having 2.8, for y decision tree is having 1.8. So it's as if from here now we can see it's more decision tree is more accurate than linear regression from what we have here in the mean square error. But let's use accuracy now. Let's use accuracy. Let me import accuracy score. Then let me see convert here. We already have our results. So I'll print for 2. So this is for linear model accuracy. Linear accuracy, I'll just give it linear accuracy. Linear accuracy, then y test, then y prediction. We name it linear predictions. Am I right? Let me check. Our y test is still the same, but linear predictions. Yeah. Tab. Put everything. So let me close this. So automatically suggesting. So this is for tree prediction, this one linear prediction. So I'll now repeat what we have here. Ctrl C for our tree prediction. So change this to linear. Change this to linear accuracy. Then we have this one is tree model accuracy. We have the tree model here, tree accuracy. So this is just like the significant figures. So decimal points that we have. Okay. Let's now use our evaluation accuracy to check there's an error somewhere. Why is this giving an error? Okay, there's a way to handle this. This is not a single prediction. You can see just like the way we have this is an array or so. So let's just try and solve this, because I can't handle a mix of multi-class or continuous targets. We'll try and fix this frame with it. I'm going to use like a for loop for each of them for accuracy. Then maybe after we take accuracy for each of them, we'll now take the average accuracy. I don't know if you get my point. We'll now take the average accuracy for them. But based on what we have here, say accuracy score is not appropriate for regression problem. Why? Because the target variable price is continuous, and since we are predicting price, regression is a value now. So let's say now the house is being sold for 250 million and you are predicting 249. No, I don't know how to put it. You can't really predict the exact amount is continuous, but at least you should be able to say, okay, your error. So mean absolute error and mean square error has already been calculated, and they are the suitable metrics for this regression task. So that answers our question. So let's just delete this. So I'll work with this. So from here now, we can deduce that decision tree is performing what? Better. So let's also analyze our results. We use explain. Explain the results here now. So you see that our decision tree is performing what? Better. Explain the results. Because our decision tree is having lower error. But now in terms of absolute error, we also need to consider that. You can see here we're having big numbers. So he said the results you provided are evaluation metrics for two different regression models. So linear regression and decision tree. So explaining what they mean. The mean absolute error measures the average magnitude of the error. You know, we are saying, like before when I was talking about accuracy, that we first calculate for each of them and the average. Now it's just like calculating the errors for each of those rows, then calculating the average. So the measures the average magnitude of the errors in a set of prediction. So without considering that direction. Now, let's say you have 250 million, as I said the other time, and our model predicts 260,000. Another one predicts maybe 240,000. You can see that you have 10,000 difference. One is plus 10,000, one is minus 10,000 and 10,000. So now that is 10,000 is the error. So by the time you calculate the errors of everything, find the average. So but for mean absolute error, it doesn't consider the direction. Whether one is adding that error to it, one is removing it, like plus or minus. So it is the average of the absolute differences between the prediction and the actual observation. So when you have a lower mean absolute error, a lower one means what? A better model. So in here now we have linear regression and this. So for mean absolute error, linear regression is performing better there. Okay, let's see. In this case now, the linear regression model has a lower what? Mean absolute error, suggesting that it has on an average smaller prediction error than the decision tree model. So you can use that, but it's not enough. Why? Because it doesn't consider direction. So for mean square error now, this now measures the average of the square of the errors. When you have your errors, you will square it, then you now find the average of the square of it. So it penalizes larger errors. So in cases where you're having larger errors, it will penalize you more for it heavily. But mean absolute error won't really penalize you. So because this one, is squaring error. So if you have larger error and you square it, you know the way your errors will multiply. So a lower mean square error also indicates a better model. So in this place now, again, sorry, linear regression is performing better. Pardon me, it was a mistake. I didn't know that there was exponential here. You can see this is times 10 raised to power 20. This is times 10 raised to power 17. You can see 2.84 times 10 raised to power 17, 1.81 times 10 raised to power 20. So I was just checking these numbers and these numbers. So looking at this, linear regression is performing better. Linear regression is performing better than decision tree. That's why we said it's best for predicting numbers. So this is performing better. I didn't even check there was exponential at the back. So again now, the linear regression model has what a significantly lower mean square error, reinforcing that it performs better. So based on these two metrics, you can say linear regression is what is performing better because it's having the lowest mean square error here, lowest MEE here, mean absolute error. So that is in conclusion. We already know linear regression is what's performing better. Based on this, don't also make the same mistake as I've made just checking this. Check your complete numbers. If you're having raised to power, you'll be able to know from that. So this is where we'll be ending hands-on section 2. So in the next section, we'll also work on another project. I think we'll also work on another one project. Probably we should still be able to have like 2 or 3 more sections. Let's see how it goes. 2 or 3 more sections. In the next section, we'll have a project. And in the other one, we can also have another project, or we just give an intro to deep learning. So for the deep learning, we won't be really diving much into it, because this series will just give an intro to it and to help us know when we use deep learning and when we use the normal classical ML. So I think we even mentioned like mostly TensorFlow, when you work with layers and neural networks and all that, already getting into deep learning. We will get into that. Thank you very much for joining today's section. See you next section. Bye.